Now you've learned how to draw graphs, we need to look at the gradient in a little bit more detail. So, previously we talked about positive gradients always going in this direction and negative gradients going in this, but that's not enough. We need to be able to calculate the exact gradient of different lines. So if we take this line, we can actually calculate the gradient using the squares on the paper. And they use a similar method all over, like for ski slopes, to actually calculate the gradient to give it a classification. When you're designing a ramp for a wheelchair, they use this method. If you were laying a patio or anything that is gently sloping away, there's guidance on gradients and how you have to build them. So what we say is you find two good points on a line and you map out how far along and how far up you need to go to get there. And the gradient, we use this formula. So we look at the difference in the y-axis, which obviously means the difference up and down, because that's where the y-axis goes. And we divide it by the difference in the x-axis, so the difference in this direction here, left and right. So 5 divided by 5 is 1. Now, if we take two other points and we do exactly the same, we can see here it's 2 and 2. And 2 divided by 2 is also 1. We could take really small ones. 1 divided by 1, that's 1. Or really big ones. 8 and 8, which is also 1. So I'm trying to get you to realise it doesn't matter where these two good points are. Whatever you have, it will always give you the same answer. So this we'd say has a gradient of 1. This one we can see is steeper, so we're expecting a number higher than 1. So good points, draw a triangle, put the numbers in, so it's 3 squares right, 9 squares up. Use our formula, so it's 9 divided by 3, which is 3. So we can say the gradient of this line is simply 3. Other points, this is probably the smallest triangle you could do, well it is, between two good points. Now we would say this and this is not a good point because it's not actually on the grid. So 3 divided by 1 is also 3. 2 and 6, 6 divided by 2 is also 3. So you can see there, it's quite easy to find. So 2 good points, any 2 good points, 4 divided by 2 is 2. So this one on the left has a gradient of 2. Find 2 good points, draw your triangle, 5 and 1. So here the gradient is 5. Negative gradients is exactly the same, but this time it's going down the way. So 2 good points, 6 and 2 do exactly the same calculation. 6 divided by 2 is 3, but because you know it's coming in this direction, it therefore has to be minus 3. Again, 3 and 9, so we're going to do 9 divided by 3, which is 3, but just chuck the negative on because you know it is coming down in this negative direction. So again, another example. So for these two, I'm just going to count along and up, so it's 4 and 2. So I'm going to do 4 divided by 2, which I know is 2, but I know it's a negative 2 because it's coming in the downwards direction. 4 and 1, so it's a 4 gradient, but because it's in the negative direction, we show that using a negative 4. So go away and try and practice some of these, and later on we're going to use this skill to draw graphs without a table of values, which is so much faster and easier.